in this problem you are expected to find the force and moment at this point O. The figure shows that it is a rod in which you have two other rods which are being fixed, and it looks like a Cartesian coordinate system. But let us draw the free body diagram for this. If you take, these are the two wires, two rods. This is going to be to a length of b by 3, and this is 2b by 3. This is 3a by 4. To this it has a uniform mass, and on the other one you have another mass. Rho is given as the mass per unit length for both the rods. So looking at it, this is my y axis, this is my x axis, and this is my. So due to rod 1, I will call this as rod 1 for simplicity sake, and this is rod 2. Rod 1 has a total mass of, which is going to be rho into. Similarly, rod 2 has a mass of rho into b. The column C also has a mass which is going to be acting like this, rho into C. I call that a rod 3 itself, its mass is rho into C. So the net force, net mass acting downwards is going to be Fo. The reaction should be equal to rho g into A plus B plus C. Very simple. Now to find the moments at rod 2 has 1/3, 2/3 hanging on either side of O. So if I considering 1/3 lengths moment, it will be rho g, which is the total mass, into L into rho g into L by 3 into L by 3 into 2, which is going to be rho g by 2 into L squared by 3 squared. And the moment is going to be, if I call this as, if this moment is clockwise, then moment due to 2/3 portion will be is rho g by 2 into 2L by 3 the whole square. Here L is B, so the moment is going to be counterclockwise. The net moment due to the rod B is going to be equal to rho g by 2 into L squared by 3 squared minus L squared into 2 squared by 3 squared, or rather it is rho g L squared by 3 into 1 by 3 the whole square minus 2 by 3 the whole square. Substituting L as B, we get moment due to rod B is going to be rho g B squared by 2 into 3. Similarly, we can show moment, and this is in the direction is, it is going to be in the ZX plane, not ZX, sorry, I am sorry, ZY plane, ZY plane. Similarly, moments due to rod A would be equal to rho g into A square by 2 into 2 in the xz plane. Hence, the net moment is a vector addition of both these moments. So, which is going to be m would be rho g by 2 into root over a to the power 4 by 4 plus b to the power 4 by 9. Thank you.